Okay, so in the last video, I was trying to describe the relationship between these emission lines and these absorption lines. So let me review that real quick. So let's say this is a gas of heated hydrogen. It's going to give off only certain wavelengths of light. And in the visible part of the spectrum, it gives off essentially these four, maybe a little bit others, but in terms of the highest intensities, definitely these four. All right. So hydrogen gas gives off these emission lines. Now, if you were to stick cool hydrogen gas in front of a star, then the light coming from the star in those particular wavelengths, also gets absorbed. The rest of the light can go through. And that's what you see all these other colors. But the light in the particular fingerprint wavelengths, so remember I discussed that this is kind of like a fingerprint. Each element has its own unique set of spectral lines given off. Well, not only are these given off by the cloud if it's heated, but they are absorbed by the cloud from other light sources. So those are the gaps you see. Those are the ones absorbed in the absorption spectrum. So that's the relationship between the two. And that's what I wanted to discuss. So you can actually use that to figure out what the cloud is made up of. Let's say it's made up of hydrogen and helium and mercury. Then you would expect to see all of these lines absorbed from a continuous spectrum, all of these lines absorbed, and all of these lines absorbed. And if you look at the sun's absorption spectrum, there's a lot of lines absorbed, right? So there's probably a lot of different molecules and whatnot absorbing things, not just a couple elements or couple molecules of gas. If you think about it, the Earth's atmosphere has quite a few different elements in it and molecules, and so you should expect to see a lot of absorption lines. So let's do a summary. Here you have a source of continuous light, and if nothing blocks it, and you spread out the light into a spectrum, you should see a continuous spectrum with no gaps. But if that same light hits goes through a cool gas cloud, then depending on what the gas is made up of, some of that light will be absorbed, and you'll see absorption lines. If that same light happens to heat up a gas cloud, then this gas cloud will give off its own light in a different direction. Notice how this line is straight, meaning the light that went through just went straight through, nothing happened to it really. But here, this line is in a different direction than the starlight. If this pure starlight were to reach the slit, it would have to go this way. So that's, according to the diagram, proof that the light coming from here is not the light from the star. It's light emitted from the gas itself. And that light from a gas is only emitted in certain wavelengths. And we did a lab, or you will do a lab, where certain gas is heated, and it's not light coming from a star that's being emitted from that gas. It's light coming from the gas being emitted from the gas when it's heated. That gives emission spectrum. So yeah, that's it. This is a short video, and that's it for light. Now we're going to move on in the next unit to stars and their life cycle. And again, just to reiterate, the only way we know anything about stars out in space is from the light coming from them. And if you think about it, I'm going to use this analogy in those videos. Same idea. If you go to a village and for a day and you want to figure out, let's say for some reason you know nothing about the aging process. So you don't know who's been around for 80 years, who's been around for 20 years, etc., etc. But what you can do is take a picture of all the people, using light, by the way. So it's a pretty good analogy in that sense. And then, ask some questions, do some research and whatnot, and try to figure out, based on those pictures, the story of that village. Who's the village elder? Who's been there for 80 years? Who was just born yesterday? who's just a kid in school, who's a young adult, and who's sort of a middle-aged person, yada yada. And so that's how we figure out the life cycle of stars through the light coming from them. So it's pretty amazing that we can figure out so much just from photons of light. All right, I'll see you in the next videos.